Is it recording? Yep, we're live. All
Oh,
right, so welcome everybody. So today we're joined by Hugo Vanthournhout. I, I hope that's the right pronunciation.
you can say it the way you want. Could be Vanthournhout if you're Dutch speaking, Vanthournhout if you're French speaking. So you're French speaking, so Vanthournhout is okay.
Thank you. Okay. And so he's a person that has a lot of experience and knowledge in the field of data. And so that's what I want to kind of talk about today. So today you're working in Tokyo as a data engineer, and you've also worked in China, also in the field of data, and you might soon be moving to another company, also and this time you'll be a data architect. So I guess the main question like that like because pe for people that are not from the field of data is like data scientist, data engineer, data analyst, and like data architects. What do they all do? Like,
Okay. Okay, what do they all do? So like what should be kind of the type of public? Or should I go a bit technical? Should I be very, very large?
I guess we can start large and get more technical after.
Okay. So yeah, data is basically everything that you do online or everything you do everywhere. Every record of any events that happens is basically data. Uh, I know people have also a definition that are way more large and they can include more stuff, but everything that is gathered somewhere is stored about you, about something, about anything, and that you can retrieve and you can have knowledge about and create knowledge from is data. So that's the main things. Nowadays, these days, this is really uh, something that a lot of people is running about, especially with AI, but even before AI, um, data, the main goal is it help you to make decision. It can help you make micro decisions, what you like, what you're gonna buy, what you're gonna sell, to whom, where to go, to find a restaurant next door. But it can also help you macro decisions, what should be a strategy and everything. So it's very large, and there's billion of it. So because there's so much money in the field, so much potential and action that can be created with data. Um, we end up each company end up with very large teams and people specialize in different fields of what you do with data. The data you want to gather it first, and then you need to gather from very different sources that are very, it could be a website, it could be an action in a mobile, it could be just a government list or something like this.
Mhm.
Then you transform it, get it what we call getting it actionable, but just you can do something with it because most of the data is too specific, too in different place. So you need to get it in one place to be able to do something with it.
Mhm.
So it's already two different steps, and that actually could end up being very different type of job you do it, getting
Mhm.
data or transforming it. Then I just try to explain quickly the flow to get to what's the jobs in there in this step. But after these transformations, you can try to understand what you do with it.
Mhm.
So try to aggregate, try something visual, try something that people understand, getting the actions, making decision with this data, because one data is one line, but
Mhm.
is often in context of million of data that you can make a decision, for instance. So
Mhm.
you need to be able to aggregate and understand what's happening. So that's another step. So you need to gather, it transforms, you need to um, make it actionable, and then you need to make decision and understand based on this data. You have another step where it's about AI nowadays
Mhm.
that is external. So in this whole mindset of a pipeline of data that I'm explaining,
Mhm.
you have different jobs and different type of things. The very first things ending with the end, so making decision on the data is data analysts.
Oh.
Data analyst is that you have already data that is well structured. Um,
Mm-hmm.
so a structure in data is more, data could be just a big text, like my name is Hugo, I'm from Belgium, nice to meet you, I'm wearing white t-shirts. Technically, there's many information in this sentence I said, but
Mm-hmm.
if you want to know the number of people that is wearing white t-shirts, just
Mm-hmm.
having this long sentence is useless. So you need to have structures like t-shirt, white, names, Hugo. So that's the structure. So the
Mm-hmm.
data analyst will take this structured data that is actionable and make decision, explain things. So it's often more about um, creating dashboard. Dashboard is basically visual of the data. It's about compute metrics. So metrics is just numbers. So for instance, number of people that wear t-shirts and number of
Mm-hmm.
compared to number of white t-shirts. So I can have a metric percentage of white t-shirts.
Mm-hmm.
So it's really more about, there's a big, often we say that the business mindset that need to happen there more than a tech mindset. You need to understand what to ask. Uh,
Oh.
you need, because you could ask million of different things to the data, but it would not specifically be useful. So you need to understand what the business want, what the business needs, those kind of things. So there is a really strong business aspect of it. From a technicality, usually it require SQL, which is a language service,
Mm-hmm.
language. So it's not really programming, but asking the data something, the language to ask the question to
Mm-hmm.
data. And it's what we have something that is linked to business analysis, that is business intelligence. That's
Mm-hmm.
another name that we could do for this data analyst. Business intelligence is more dashboard, like really the visual aspect of it.
Mm-hmm.
We create business intelligence because it's understanding the business, basically.
Mm-hmm.
So
So,
that's one aspect.
so like data analyst is really like the link between like kind of the human world where it's like, oh, I want like I have a question and I want an answer, and
Mm-hmm.
like I be able to make easy decision from like the business side, and then the data world where it's like,
Mm-hmm.
right? Okay.
Yeah. Yeah. Knowing that the data is already be ready to be used.
Mm-hmm.
So it's not, you're not gonna make a decision based on the 5 different clicks that someone did in this iPhone, because
Mm-hmm.
it's not really something you can use. But the data is already aggregated, is already ready to be used.
And
And
that's
so, mhm.
to make the data ready to be used.
Yeah, that's more data engineering. That I will come later.
Oh, okay.
So and one thing is I'm describing a lot of jobs here. So I already
Mm-hmm.
started with data analyst. I will go after data scientist. I will go
Mm-hmm.
to data engineering, maybe first data engineering and then data scientist. Maybe
Okay.
data scientist first because it's in the end of the pipeline. So like, I
Oh.
got that until the end. But what I've noticed is that like in a lot of things in companies, names might mean different things.
Mm-hmm.
And for some company, for instance, data analysts will be just asking question on the data and be very business. So I think
Mm-hmm.
some company might incorporate a lot of data engineering as well.
Mm-hmm.
In some company will incorporate a lot of data scientists. So
Mm-hmm.
it really, I'm explaining the general idea, knowing that if you work in a company later, they might mean something different.
Mm-hmm. Okay.
So that's one things. Maybe now I will go to data scientists because they happen kind of in the same pipeline where you get the data down and they have this structured data that is being created. And then data analysts make the decision, data scientists will use the same data that data analysts to make decisions, but to let
Mm-hmm.
AI make decisions. So data
Mm-hmm.
analysts usually gonna make the thinking
Mm-hmm.
and make the compute for humans to make decisions. Data scientists will let the the the, the machine do it for you. Uh,
Okay.
letting the machine do it for you have different advantage, some disadvantage. I will say that, for instance, if you want to really understand what's happening in your business,
Mm-hmm.
An AI can tell you what to do,
Mm-hmm.
but sometimes what to do, you need to understand why you do it to do it effectively.
Mm-hmm.
And also to understand if the decision is actually right. It's really good to know why it has been made. So having
Mm-hmm.
a human that understand the business, also there's a lot of communication often that is needed, and like a lot of knowledge that is not in the data actually that come from somewhere else. And discussing with someone, you can increase something. Well, the machine will always make decision by themselves on what you give them. So
Mm-hmm.
having and also training a machine to be able to make decisions can take a lot of times. And so
Mm-hmm.
that analysis will be more iteratively making question all the times. So that's the data scientist part of it. Um,
Mm-hmm.
is basically not making the decision on data himself, but creating a machine that can learn from the data to make a decision for him. So like
So,
who you want to sell, what do you
mm,
want to sell? How much do you think you will make next year's? How much do you think you need in your stock
mm,
to be able to all the demands? Who should recommend what? What should be the marketing strategy? Who should be the groups of people? How much group of people do you have? What their profile or they look like? That's gonna be more um, data scientist because you need what I call a machine, but it's basically an artificial intelligence to
mhm,
understand and to. It's not always complex. That's something is important to say, is that
mhm,
we think something that is like when we have neural network with a million and million of different parameters and everything. Sometimes it's just what's the closest data in your data sets to the data you receive, and that will work super well. So
mhm,
it doesn't have to be ultra complex. It can be complex. Often you will have a lot of vague area between a data analyst and a data scientist because
mhm,
you can use AI to make intermediate decision or intermediate understanding, and then you will have a data analyst that will use that as well as input. So it's not like very separate. It could be a little bit in the middle.
mhm,
Um, Data scientist, there's a lot of things around it nowadays. You can hear things like AI, um, AI engineers and everything. It's
mhm,
because working with those machines that make decision is becoming more and more complex.
mhm,
It need more and more iterations. There's more and more infrastructure behind, so
mhm,
servers and everything. So now it's not just about starting the things. It's how can you scale those kind of things? How can you make decisions with billion of data? So there's more of a why data scientist before was more in the research. Often it's seen like this for us, like a data scientist will do more research,
mhm,
while the AI engineers is more application, more infrastructures. It's not playing around, it's more setting up like something uh,
mhm,
more complex technically without it's not really more complex because research is very complex, but more software engineering side of it,
mhm.
while data engineer will be more focused on the AI and the research aspect of it.
And
um
will a company usually have one person that's the data analyst and one that's a data scientist, or will they combine the two roles as one
Normally
person?
there is difference because often
Mm-hmm.
data analysts are more working with the business directly, so
Okay.
usually you have different profile.
Mm-hmm.
What you have is sometimes product manager that are working as data analysts.
Mm-hmm.
It depends a lot of companies. If you
Mm-hmm.
are a very, very small company, data scientists will be doing data analysis. There's also a lot of company that will hire data scientists
Mm-hmm.
because it's fancy nowadays, but in
Mm-hmm.
practice, you will be doing data analyst jobs.
Okay. Okay.
Or
Okay. Okay.
you will have a small AI on the side for the fun, but what the real reason they're hiring you is to do a data analyst job that is kind of more easy to get value directly.
Mm-hmm.
So it's starting to change. But when I started to work, data analyst is really well established. So you know how to get value, how to
Mm-hmm.
get data. And it's also really the most useful person for the business because he will explain the things to the business person that will make the decision, while the
Mhm.
AI will make the decision for the business person. So it's usually it's where you can get very quickly value on your data, while AI models is hard to understand. It's
Mhm.
not always stable over times.
Mhm.
Often is really depending on your data itself that you have, while the analyst can make understanding of, oh, the data look weird, doesn't look with what we've seen before. Let's try to see, understand why, and play around, remove what's not good, discuss with
Mhm.
these persons, make some hypothesis and everything. The AI models will just take what they have.
Mhm.
And so you need something that works very well, that is very clean, a really good platform to have really AI that is really delivering in terms of value for an enterprise, creating good decision, creating uh, good insights, or directing people in the right decision, in the right directions and
Mhm.
everything. It can create way more value because it's automatic. So if you have something that works very well, you can make it work for everything very well. And often the human brain is really limited in what it can do. It can only think to a certain level in terms of skills. It can, in terms of dimensions, different features. It's like different column of data, just to simplify.
Mhm.
Um, so as an analyst, you can make decisions that are to the scale that what human can think. That also means that the person that will receive the information, the business person, will receive something that is his skills that he can understand.
Mhm.
While AI models, often they will go more complex. Yeah,
Is
sorry,
it
I went too far in the data scientists and architects and not going really to the different jobs, but it's to explain a little bit what's happening there.
it's just yeah, it's kind of complex. Like, is a big part of the job of like data scientists to kind of explain to like the decision leaders within the company why the AI does what it does? Or
It's part of the job, but it's not always. Depends what you do.
Mhm.
So, for instance, if you want to forecast your future revenue, you better
Mhm.
have a real understanding of why
Mhm.
you make a decision. If you're creating an AI that is hiring people, super
Mhm.
important to know why, because you don't want to have something that is not ethical or something like this.
Mhm.
But if you want to recommend stuff to people and you want to recommend thousands of different objects per second, like what I'm doing in let's say the e-commerce company I'm working on, and you have million of products and million of users,
Mhm.
doesn't make sense to really explain. You just want to make sure that explain you to which extent you are sure that the AI is working.
Yeah.
There's a big aspect. Sorry, I should maybe switch to different jobs, but for science, there's a big aspect of creating the machine is not really time consuming. It's very quick to be done. You don't really create an algorithm. The algorithm is already made for you. Usually you just adapt it. Um, the big aspect of data scientists is often understanding the data that you have. What data do you have? Is it good quality? Is it so getting the data ready for the AI models and
Mhm.
um, and really understand how well it's working, how well your confidence on it's working, uh,
Mhm.
like and how to improve it
Mhm.
if it's not working well, and interact a little bit like just having, for instance, I don't want to go too much technically, but a big aspect of it is yeah finding accuracy, but not just the accuracy, a bit more than that, and explaining how much your AI will work and what you should expect for it.
Mhm. Like recall, precision, and
Yeah, those kind of things.
okay.
And so you have a lot of things you need to explain because business people will not understand what precision, recall, and everything.
Mhm.
That's a big aspect of it um, that I've seen. So let me just then go back to the different jobs
Oh,
again, because I went directly more in the data science. But to
yeah.
understand really what's the end output could be decision made by human and decision made by machine data scientists.
Mhm.
More infrastructure around those machine AI engineers.
Mm-hmm.
Then data engineers is more getting this data. That is really, yeah, data is not really a funny word. It can be a bit boring, but I often think about data more as a kind of chemistry,
Mm-hmm.
where you have pipeline, you have different raw ingredients, and then you need to mix them in big pipeline, and then you need to have an output somewhere at the end.
Mm-hmm.
That could be your plastics, and you could have like some different product there. The data scientists will do a lot of if I take a little bit of this petroleum theirs and I add 5 grams of this and 5 grams of this, oh, I have in the end one big plastics. The engineering, it will be more building than, okay, I know they need that,
Mm-hmm.
a certain percentage of this product, this product, this product. Now
Mm-hmm.
I'm going to create a very big pipeline of everything, of all the product that we will receive ever
Mm-hmm.
on certain quantity. I will clean it. I will select it, what only of it. I will get it ready in the place I want. I will make sure that it respects the security aspect of it. That it's not gonna break up the whole factory. I'm gonna make sure that nobody gonna steal the product, and then I'm gonna get it ready to this place to have the final plastics. So it's a
Mm-hmm.
big about more of an infrastructure side of it.
Mm-hmm.
So is what's actually there's more in demands in the market, because like I saying, usually you have one data scientist for 7 or 8 data engineers,
Oh.
and you don't have to think that it means it's less technical, or actually you even often make more money as data engineers than data scientists, but it's just more in terms of requirement from the enterprise,
Mm-hmm.
because you can have one guy that make decisions, but to have the full factory working, you will have to create the early formula. But then the formula is there. And
Mm-hmm.
it's more about how to build this whole factory, or to scale this factory to have more plastics, or to make sure I should not use plastic too much, because now I'm gonna work for an NGO. But are you gonna so oh, these factories are to be a bit old, so we need a new one. Or there's these new fancy things to be cheaper, or I should put it theirs and everything. So you
Mm-hmm.
have more work. You can understand that in factory there's actually more work to do theirs than actually creating the the very first formula. It's the same with data. We have a lot of things in the cloud now, so a lot of different servers that could be either in your company or it could be in someone else, but you work on there, someone
Mm-hmm.
else. And you could have a little bit of data, then it's easy. You just copy it from X, from R's. You make sure that your data don't have a lot of false stuff, or they follow the very same structure that you want.
Mm-hmm.
I think when I tell you about the t-shirt, white, you need to be t-shirt, and then it be white. All the white need to be the same, because
Mm-hmm.
if you say white with S in the end, then it's a different field. There's a big aspect. There's also, imagine you have million of data, and you want to make an aggregation. So aggregation is just, let's say, a sum will be an aggregation, or maximum. So you want to have a value based on all the data. Sometimes the scientists will just not be able, data scientists will not be able to do it because there's just too much data. So his computer will not handle it. So you need to prepare a lot of different, what we call features, but like, okay, based on the fact there is t-shirts and there is this, then we can say like t-shirt. No, that's more data scientist stuff actually. So it's not really a good example, but we're gonna
Mm-hmm.
create we're gonna clean the things, we're gonna extract the different data field. Something that is a bit more mechanical. I don't really like that actually of it.
Mm-hmm.
Is more sometimes what I will say in data engineering is you will want to play around a bit more,
Mm-hmm.
but you play more not really on what you do on the data, but what you do around the data. How do you scale?
Mm-hmm.
How do you have 10 servers working at the same times, or you make sure that you
Mhm.
don't have cost, or you make sure that if you want to make change, it's not gonna break everything.
Mhm.
And like, oh, I want to add a new pipe on my pipelines of products. How can I make sure that actually the current flow that is running is not breaking? So there's
Mhm.
a lot of aspect of more computer science to it
Mhm.
than just playing around the data that could be more scientific, or that could be more business side.
Mhm.
Um, so yeah, so that's the data engineering. Also, getting the data at the source is
Mhm.
often done by data engineering. It's a different type of data engineering, but it's also data engineering. So that's the overall idea. On top of those people that really create the big pipeline, I'm talking too
Mhm.
much. I'm sorry.
No,
See
no,
your
no.
question down me because I feel uh,
You're on a podcast, like.
okay. So I keep going. So on top of all those pipelines, you
Mhm.
have people that manage those people.
Mhm.
You have people that make sure that what's inside respects some rules. You
Mhm.
have people, for instance, in the factory of chemical, you will have people that will look if you respect all the circular aspects that a factory should have.
Mhm.
You have people, I think it's called GRE in the factory, but like someone that will make sure that every employee respect the rules to not break everything. Make sure
Mhm.
that nobody stole anything. Make sure that people can only access what they need to access, and that's um, so. For that, there's also different roles. I can just throw some names. There's data governance. Data governance is more who have access to what, because when you talk about data, you talk about human people data, private data, uh,
Mhm.
could be health data, could be financial data, could be also just data that belong to a certain company.
Mhm.
So all of these have a lot of set of rules. You might have heard GDPRs, but it's not only GDPR. So that's the governance aspect of it. Is who can access data, in which way, who's gonna pay for it, who is responsible, what these fields mean actually. When you talk about plastic, what do you mean by plastic? Because
Mhm.
maybe for this company it's a plastic, but for this person, this is not a plastic. As a
Mhm.
manager data governance. Um, definitions, access, and everything. You have data managers,
Mhm.
basically managers in the world of data.
Mhm.
So they need to understand everything I explained. They need to understand is doing what, and you need people that are kind of intermediary between a data scientist that is doing his own stuff, a data analyst is doing his own stuff, data engineering that do their own stuff, and that
Mhm.
if data engineering change something, he might change something for data analyst and data scientist, but they don't know, and then everything starts to break. If data
Mhm.
scientist wants something new or is doing something that is wrong with the data because he's stupid or don't understand what you want. Then you need to have you need to make these all teams work together, and you need someone that have a visions to make people working in the same direction. Often it's going to be data managers.
Mhm.
Um, and sometimes when people like, but this is what I was telling you also about. It depends what it means for company,
Mhm.
because I tell you data governance, data managers, sometimes it's the same position.
Mhm.
Sometimes it's different. You have a lot of things that is related to software engineering that's
Mhm.
there because it's all about computer making code, pipeline of data. So you have what we call CI/CD. I don't want to go too much in detail because that's hard, but deploying stuff
Mhm.
basically. Like I was telling you, or add a new pipe without breaking the other pipe, for instance. Or do you make sure, or do you test those kind of things? Uh,
Mhm.
you have, yeah, I know there's more that is just related to pure software engineering that you will find in any project of software engineering around it. I think I did it all. Do you have question?
Mm. You didn't talk about data architect, really, no? Or
Mm. So yeah, the data architect is, I was talking about things that could be different in a lot of company. This
Mhm.
is like the most of all,
Mhm.
because it could be really a lot of different things depending on what people mean by it. The
Okay.
the general idea of architects, is really what is means to come back to the chemical factory is
Mm-hmm.
the architect of the chemical company. So it's like the person that have a full visions of how do we build these all things and how it should be built. What's the best practice to be built? Because you can build a factory that do plastics thousands of different way, and for
Mm-hmm.
data is even more. There is really, there's not one way to do things. There's a million way to do the same things. And you need to understand what are kind of the trade-off of different decisions, what you can earn by making this decision, what you can lose by it. So often, usually as architects are more people that have worked.
Mm-hmm.
You don't start as a data architect usually. You need to have really understanding of the business already, understanding of the technicality of making this pipeline, because if you want to understand trade-off, you need to understand the technology behind.
Mm-hmm.
And they will tell you, okay, you want to do a new platforms for your data because you have data that is in this place, but you don't really know it work, and you heard about these new things in the cloud. So what will be the cost of moving to cloud? What will be the gain? What's if you do that, what should be decision do you do? How do you make sure? How do you actually transfer data from there to theirs? Or in which way? Which tool should you use? For instance, for data, there's a big aspect. We sell the 3V. We're going
Mm-hmm.
into detail. So it's like velocity. Oh, I should type it. I don't know by head. I'm very bad at memory stuff. But let me just type it in a second to just have them be the 3V of data to explain what's. So you have very volume, velocity, variety. So your data could have a different type of volume. So you could have 10 line of data. So you have 10 people that work
Mm-hmm.
for your company, and you have the salary data. And so you have just 10 line for these 10 people. Very small. But you could have also a billion of user in Facebook.
Mm-hmm.
So how do you do data transformations? How you do understand your data? How do you compute stuff? How do you make logical transformation on those data? Might
Mm-hmm.
vary a lot if you have just 10 line of data, where you're going to store it, or if you have very high volume. Velocity is more about um, do you want, so you have your data that is there. Do you want
Mm-hmm.
to make a decision right now? Do you need
Mm-hmm.
to have the data right now in front of you as person click on the button and you want to see that your data change and have a +1 number of click, or
Mm-hmm.
you can wait 1 day for it. The
Mm-hmm.
main difference will be, for instance, if you want a recommendation system,
Mm-hmm.
you need the data straight up to make a new recommendation. You don't want to wait 2 weeks to recommend buying a new phone if the guy is looking for a new phone right now,
Mm-hmm.
because in 2 weeks he will have already buy it. So you need to make decisions straight up. So the velocity will be very high. But
Mm-hmm.
if you want to do your quarterly record of all the different things that you sell and have a vision of what happened those last 3 months, you
Mm-hmm.
don't need to do it again every second.
Yeah, you can.
And sometimes it's also very not possible, because you will have different um, company that need to aggregate themselves on the side the data and then give it to that. So you can get the data at different speeds. And then you have variety. It's more what type of data. Do you have a data that is already really well structured? Like I was taking you about t-shirt. It could be a big sentences, or it could be different field of data.
Mm-hmm.
So what type of different? Do you have pictures? Because picture is technically data. You could get value. You could recognize what's happening in the pictures, and then you can have data about the number of dogs that have been photographed in the last 5 years. It's a question you can ask to your data based on pictures. So yeah, you have those 3 different V, and depending on your data,
Mm-hmm.
on those type of different requirements, you will need very different architectures, very
Mm-hmm.
different flow of data, very different type of technology. You have
Mm-hmm.
streaming technology, very fast. You have batch technology that are more very big data, but doing once a day, for instance.
Mm-hmm.
So like for stream, just to throw some names, you have more like Kafka, you have those type of queue systems, Rabbit and everything. While for big data, you have Spark, you have more just other type of database like Redshift or Snowflakes, BigQuery and everything. All those kind of things might depends on the context.
Mm-hmm.
There's a cost aspect of it. There is understand what already exists and that you don't want to recreate everything from scratch. So you need to understand what already exists. You need to understand how is the data. You need to understand what is the needs of the business. Do they just need to see one dashboard because technically they don't have any need of AI? Or do they
Mm-hmm.
need a really complex AI that will require a million of data? All
Mm-hmm.
those kind of things. Or where are you going to get the data? What are different? Yeah. So that's going
Mm-hmm.
to be more data architects. In a lot of company, actually, this is kind of the decision that is made more by agreement between different people. You will
Mm-hmm.
have data engineers that will make decision on the scales of what could be in data engineers. And then the manager will discuss and certain is what they want. They will discuss with the business what they want. And then they will try to ask people to add all the part, and then all the part are going to be put together. But more and more we see we need like someone that is really technical, that have these all global visions, that will do the discussion with the different
Mm-hmm.
users, but that will also have their own opinion on how the thing should be done.
Mm-hmm. To be more like forward thinking instead of just kind of reacting to
Yeah,
whichever the moment.
yeah. Things added there and there. So you need to also understand what's happening in the business. What are the different possibility? What is kind of trendy? What is, yeah, those kind of things.
It seems to me like all of these roles, like you need a very different personality in order to fit in all of them. For instance, like data analyst, you need to be a very good communicator and a very good empath.
Yeah,
While like
you need to understand people and what they need, and to
for
explain to
data,
people what they can have as well. So there's a really human aspect of it.
hmm
But
and
you still
like
need to be technical. Sorry, I interrupt you. Go ahead. Go ahead.
for data engineer, you need to be rooted, like you need to have a lot of like knowledge about like IT hardware, right? And like the IT infrastructure. While in
Mm,
data scientist, you can be more of a math person, like
yeah,
math, AI and coding.
yeah. I don't like math person because nowadays this really you really do maths
Yeah.
in data scientists, but you need to have a research mindset.
Mm-hmm.
You need to sometimes it's also dangerous research mindset because you need something very concrete that can be really actionable and used by other people. And it's very dangerous to have something that is too kind of high hands and or too play around. Too, I do a lot of if else statements and then I use an optimization for there and there's.
Mm-hmm.
When you want to create full platforms, you want something that is really usable, but
Yeah.
you need to be really interested by those kind of things. And
Mm-hmm.
um, yeah, to play, you need to have a play around type of mindset,
Mm-hmm.
I would say.
Yeah.
Um, yeah, and that architects, I don't know what you need, but yeah, I think that architects you need to be good at have like to be very visual in your minds, understanding and good at putting all the pieces in your head together and have a visions on other things, understanding all the whole flow from A to B, I would say. So for me, why I moved to architects, I
Mm-hmm.
think that I'm a guy that really like to touch everything in terms
Mm-hmm.
of personality.
Yeah.
I get really excited by new things, trying things around. Also, my career is just by pure random aspect of it. I worked in very different type of company. I work
Mm-hmm.
in consulting. I work in a big IT company, with very large scale data, but I also worked in startup. I have still good scale of data, but less bigger scale. I've seen different type of like what we say on-premise, so your own server that you belong to you, or I've seen pure cloud stuff as well. So the fact that I touched to a lot of things that I'm very curious about different things, make it good for, and I'm also really good at visualizing the whole things together. So that make me good for data architect. Data engineers, what I've seen right now on data engineers, I really like it at the beginning when I was learning, but I see that it doesn't match very well my personality because I can get a bit bored. I will like the design parts of the things, but doing it was very nice at the beginning. Not I've done many times. I get less. Sometimes it's all too much. You try something and then there's bugs, and then you start spending your life fixing bugs more than trying to think about the whole flow of everything. You just need to make sure everything is clean, working well, and that each detail is taken care of. And I can do it. I'm good at it, but it's not where my personality shine, I will say. And you, what should be your personality, you think, in this type of pipeline of data? If you become working in data, if one day you work in data.
I went to work in data. I do have a bit of a generalist personality, and I think I definitely have the play around side as well. That, like you said, for data scientists, like I agree, it can be kind of stressful when you're like playing around, but at the same time, you feel like the company is expecting like something from you. Quite antithetical, right? It's like they're expecting a very concrete results, and you don't like
Yeah.
the whole of like trying new things is that you don't know if they work. So
Yeah, this is why there's this new position of AI engineer that is really those last five years that is really because it's really more on the concrete aspect of the AI. Way more in the product, what we call putting to productions AI model. So you can store different version of those machines. So what type? I try once in version that is currently working, but I have a new version that is coming. Or do I make sure this new version, and I make sure this new version is working well, better than the other one, or sure I can replace, or I can create an environment for data scientists to actually play around quickly and not spending a lot of time to just really have starting to play around. Or I can make sure that those AI models actually, you can train them, but or that you need to make sure that they're actually working in reality. And how do you make sure that they are technically working in million of users? So this AI engineer is a bit of a mix of data engineers because there's a big infrastructure creating this big factory mindset, but more for the pure machine that made the decision than the data itself.
Yeah, I think that could be a good fit.
Mm.
Actually, yeah, that was kind of one of that's related a bit to one of my question. It's like right now there's an AI revolution going, right? We got like ChatGPT, we got like
Mm.
new machine learning models, we keep like, and so how has that like impacted the industry, like the
Mm.
limitations, the techniques of doing stuff? Like I imagine data is like the most impacted industry, right, by this.
Yes and no, because it's so yes, of course, yes. It is not really a no. It's yes, but in different way. Because the
Mhm,
way those ML models work right now is actually a bit different from what we do in data. Is API call. So you use a service that do everything for you. You just
mhm,
connect to it and receive the data. Which
mhm.
really different from what I explained you where you have your own pipeline from everything that do the
Yeah.
decision. So that's the difference.
Mhm,
I think it will depends a lot as well on the scale of the data because
mhm,
you cannot do the same thing to a billion of data that you can do to 100 data.
mhm,
That's one thing. Um, so right now, what I see it's that people are not really sure. It was the same with data science before.
mhm,
You need to figure out where the value is.
Mm-hmm.
So you can have people doing big talk about is there futures and everything, and maybe we'll change everything. But the business work usually a bit slower than that. When I started, it was really hyped to data scientists. So you have like some library like sklearn and everything. So people were learning all the things, the algorithm, and then they were just applying there. And there was a lot of money for that. And
Mm-hmm.
a lot of data scientists were hires. They just do some five different online courses, and then the data scientists, even though they are not technical. Um, the so there was a lot of money then, but then the value didn't come
Mm-hmm.
directly. It comes slowly and it's now already theirs, totally theirs. But at the very beginning, especially for smaller company, it was very
Mm-hmm.
hard to have direct value because they didn't have really a good infrastructure of data. It didn't have really good data, so they didn't have very good data. It was making bad decision. So
Yeah.
and they also didn't know how to use it multiple times and how to make sure decision automatically and everything. So he had a shift afterward in, oh, we need better infrastructure. So he went to data engineering and people started to hire all of data engineering. And then
Mm-hmm.
the data started to be good. So then data scientists become a bit better, more in use, practical.
Mm-hmm.
And and you have all the things that build there. So I what I've seen right now is a lot of people do POC, proof of concept,
Mm-hmm.
what we can do with it. There's a big aspect of people that use your data right now. The easy use case is how can we make people use better your data, understanding your data. A big things I'm seeing a lot of things as well that is really good in the data field is like if you have a really long text, like I told you, my name is Hugo, I have a t-shirt, white. Actually getting the data out of those very long texts, very complicated. But those they can do the work for you
Mm-hmm.
and get something structures. I think it actually has more impact on the short terms, more on the application side. So
Mm-hmm.
backend content, I don't know if it talked to you, but you can make like you click on the button and then you have an information that comes straight up. So it's
Mm-hmm.
not a full pipeline of data, but directly in action need an answer.
Mm-hmm.
And there I see a lot of things. Sorry, I'm a bit vague. Huh? One big aspect of AI I've seen in my field, but it's any that has any software is
Mm-hmm.
the very short-term things that I'm saying is actually not on the transformation of data, even though it's coming. It's totally coming. It's just still not fully there, especially in smaller company. But it's more about we use the complexity
Mm-hmm.
because those LLMs they are very good at parsing a lot of information and that
Mm-hmm.
is in the internet, remembering a lot of documentations,
Mm-hmm.
retrieving the information in these documentations, um, and telling you what you do. And also, the field is a lot of what already exists, and you need to copy it, transform it for your use case. Those kind of things that is very good. So what I see is like people use that daily all the time to make decisions. And it's actually very, very good. I think that's one of the things that is good at software engineering. It's very weird because it's seen as something very complex. But a lot
Mm-hmm.
of things in my job is actually asking the right question to Google.
Mm-hmm.
Is I know what I need and I need to say what's the best tools that do that, and that, for instance. Or I have these tools and I want to do these things. I know you can do it, but I forgot how to do it. How do you
Mm-hmm.
do it again? And he will tell you. All those kind of things, the those LLM help you very well and they do very good things. Or I have something that doesn't work well. I have an error message. I don't really understand what it means, but
Mm-hmm.
actually in the internet is somewhere. So before you were going to something is called Stack Overflow that will just all the people that do coding type theirs, and then you will retrieve someone that have the same issue as you, and then you will resolve it. But now LLM just do it for you. You don't even have to go to find it. He will tell you, oh yeah, I've seen 10 million times the internet, and I remember that in this stage they say that, and he will tell you to do that. So that's one thing, and they have a big impact for me is that before there was really an aspect where a very good software engineers, a very good data engineers, really good data architects could change the world for a company. Where he could be doing something himself by making the right decision, by knowing what to do, by being good at fixing issue and avoiding issue before they arrive, make a project work by itself, and have ton of value for a company. And this is why you were seeing so big salary in the US, for instance, because it could be a very game changer to have the best there. Nowadays, the LLMs, they kind of remove they remove a lot of barrier to entry. And you see a lot of company right now that are very heavily investing in cheaper country because where before the education system were not good enough, or the company there were not good enough, so people didn't have the right experience, they didn't have good experience with the best practices, and everything's kind of, all those kind of things reduce the access. And this is why you see a lot of layoff, a lot of recruitment in the same times, country like Mexico and India, or everything's. So that have an aspect. First, that it's not very nice, but it's good for them, to be fair. But for us, is that we're less marketable, I will say.
So like the skilled worker that before could tell the employer like, yeah, I have this skill, so you need to pay me this much. Now, like the employer has many more people, like access to more people with this skill. So
yeah, and it's also going with the fact that people in those countries are starting to get better. So it's a mix of, it's not just because the LLMs is there, it's also those people are starting to get better, and it make the next step. It's also the communication gap. So I don't want to say they were not good, but there was a lot of people saying, oh, you can go hire people in another country, but you're not gonna make the things happen. And it was often right, just because there was a communication issue or technology, they were not really used to it, or they didn't really understand what needed to be done. It's like this. Nowadays, yeah, it's less and less the case, and on top of LLM, even this gap, reduce this gap even more. So that's one aspect. I think there will be a more happening in the pipelines business aspects, but more in 2-3 years, I feel. There's something very big that is happening. I've seen a lot is what we call RAG. So those LLM, they're really good at retrieving stuff, like I told you, like information on how to do things. But on the internet, what's publicly available, or at least what is being given to that. The thing is, companies have very big data themselves, but they are their own data, their own documentation on what they work on, or what is used on what type of data they have, what data is, what type, what's in it, on the users, on the documentations, on everything. So there's a big field right now to what's called RAG. Is more to how can we use those LLM to actually use our own data? Because right now it's just on the side of OpenAI or the competitors, but we don't want them to have access to our data. So there's different services. You can do different things. You can use an open source or use service from OpenAI to train on your own data. That's one thing. You could also use services to actually to help the LLM to retrieve the informations from your database of data, of documents, to use it as a context to your decisions. So for instance, if you want to do data transformation or understand your data, you ask him which data do we have that could correspond to finding the specific group of users that are that like pink cats. And then you say, oh, okay, we have data about animals, we have data about colors, that is in this table and this table. It's technically in the documentation of the enterprise, the company, sorry for my French. they will have something that will retrieve the exact page that they need.
Mm-hmm.
About cats. Okay, this is the schema of user liking cat. This is the schema, I mean, by the different field that we have. This is another table. So table is where we store the data, where you have all the data there's about colors. Okay, we're gonna mix them together, and oh, you should do that. And there's a big aspect of replacing the data analyst there,
Mm-hmm.
because you could have a business person asking questions,
Mm-hmm.
and then the AI can make the decision for them. Can do okay. It can even write querying language, so
Mm-hmm.
it can tell you, okay, I know that there's this table, I retrieve that. I know there's this table, I retrieve that. It's like this. And okay, so what I will do is I will do a select style, and I will join those two tables together, get the data, this field and this field, do a count on it, go by people that are like this, like this. I'm doing too much in details, but then,
Mm-hmm.
and get the data, and it will just execute that, the code that the LLM creates, and get the answer directly to the end users.
Mm-hmm.
So it will replace the data analyst, because it's the person that do the most humans language aspect,
Mm-hmm.
because you
Yeah.
need to talk to the business and you need to talk to the data. So this is actually what the LLM is good at, is understand what the business want, the questions, and
Mm-hmm.
and then put it in the mathematical space, and then link it to the specific data. That's really, he's really good at doing that. I recognize different terms together. So
Mm-hmm.
that's one aspect of it. I don't think it will fully replace. I think it
Mm-hmm.
will be kind of a tool that you use on top. Like you
Mm-hmm.
will have a dashboard, and you will have also ask a question, and then people will ask the question, but you will have the general dashboard that is there as well. So,
Mm-hmm.
and yeah, when you have really, after that, people will understand what people is asking them, and
Mm-hmm.
where it can create. Like I told you, he can also have an aspect where he structure the data, so he will arrive to that engineering as well.
Mm-hmm.
And then most likely after a while, you could use LLM to build your own AI quickly,
Mm-hmm.
iteratively. So it will go more and more and more, but I think it will take a bit of time to get there.
Mm-hmm.
And it's gonna be a different speed than the research. So
Mm-hmm.
it's not like if the research tell you we have the new model that is the best, that can do everything.
Mm-hmm.
You need to think that the industry is most likely looking at the model that actually was out years ago or something like this. So it will take times. I'm not saying the AI will not go fast. I'm taking the adoptions by the company take times overall of new technology.
Like there's a bit of inertia because like companies tend to be a bit conservative, right, with the adoption of
Yeah, but it's also that it's complicated.
Mm.
Change. So it's not like people don't want to work. It's more if you change that, there's a big risk. That's, are you sure that it's gonna also make the good decisions? Are you
Mm-hmm.
sure that it's actually working well? Because
Mm-hmm.
yeah, it's, sometimes you can do very complex things, complex AI tools that will tell you if someone is selling Coca-Cola or not.
Mm-hmm.
And then if you just actually were looking if the word Coca-Cola was in the sentence, you will have
Mm-hmm.
an accuracy that will be 10 times better than the AI models that you train,
Mm.
because it's badly trained or because whatever reasons. So it's you need to take care sometimes, because for instance, a lot of things that those LLM can do, a
Mm-hmm.
good pipeline can do it already. And
Mm-hmm.
a good pipeline doesn't need to do a call to internet to receive the data from theirs. Doesn't need a super large models, because those models, they are very large in size. So it will take not all your memory. And imagine that you are actually working in 12, 13 different computers. You need to duplicate this model in 30 computer working in parallels and everything. And it starts to be a lot of money. And so like your company, someone tell you, oh, everything that you're doing, you could do on LLMs. It will be wrong sometime, but right most of the times. And if we
Mm-hmm.
call, well, currently your pipeline is right more times than the LLM, and
Mm-hmm.
it will cost you 10 times more.
Mm-hmm.
So these will be at times a little bit. I think that's why people are trying to reduce. I mean, a bit too technical as well, but the size of the things, the
Mm-hmm.
cost of the different things will go down. The tools around this, because in company you don't really like to use to play around.
Mm-hmm. Yeah.
You like to have the same thing that everyone use, because if you guys is leaving, you need someone to come in and work on it directly. You need
Mm-hmm.
people from another teams to be able to work on it. You need to be able to share to different teams. So usually
Mm-hmm.
what you look for is not the new fancy things, it's what everyone use. And so
Mm-hmm.
you need to have people to make an agreement on what everyone use. And that
Mm-hmm.
takes a little bit of times. Like we talk about library, like sklearn or transformers library, data science stuff.
Mm-hmm.
Nowadays, most of the time, there is a really commonly used library for all those things. But at the
Mm-hmm.
very beginning, there was 20 different way to do these things. And
Mm-hmm.
before it was accepted as a common standard and everything. And so usually a company will wait for those common standard to appear to start to adopt it.
Mm-hmm.
And they will wait to actually see the real value before adopting it. They will do a
Mm-hmm.
lot of small, what we call proof of concept, just proving that it's possible. But it doesn't mean they will replace everything.
Okay. And so if someone like wants to get into the field, so I imagine it's different for like different jobs. So like what are like the most in-demand skills you would say like in the industry?
And the main skills right now is data engineering.
Mm-hmm.
So there was a lot of people that joined that. So when I joined, it's just 7 years ago. So it's not that long ago, but on my field, it's a lot of time.
Mm-hmm.
Because it's 7 years ago, but it's something that is 10 years old. That is based on thing that is way older than that. But the pure hype, really infrastructures, everything's the scales and everything is the technology that is in use, that is mostly in use everywhere, is really started to boom 10 years ago. The AI
Mm-hmm.
and everything is 40 years old stuff, but 10 years ago. Uh,
Mm-hmm.
Back then, everyone wanted to be a data scientist because it was the new futures, and everyone could be a data scientist. That was kind of the funny thing, is that you didn't need it to be a technical guys to be a data
Mm-hmm.
scientist. You need just to do some online courses and you were there. Problem then is that there was a lot of proof of concept everywhere, so there was a lot of jobs and not a lot of people that were knowing how to do that. Then too
Mm-hmm.
much people enter the things, and at the same time, all those proof of concepts stop it to they were done, so and no value added, so they stopped doing it. So
Mm-hmm.
a lot of people moved to data engineering because that's what all the enterprise were doing now.
Mm-hmm.
I think that is still there is that the main issue for company right now is to have what we call data platforms. So
Mm-hmm.
just like a very standardized way to use your data, to have it accessible, to be sure people can access it and do some stuff on it. And so that gets everything included from different sources, and then you can start. So basically a really clean stuff.
Mm-hmm.
So there's still a lot of work to be done there. So data engineering is really on demand because this is where there is the most work to do.
Mm-hmm.
Um, I think that sometime doing the hype stuff is
Mm-hmm.
really good to start as well, because people that work for a while, they get less excited, so they're gonna be less in the hype. And
Mm-hmm.
often in the hype, there is money. So people can still recruit people, and they will be interested by new motivated person that just did the new things that they're looking for. So actually working on LLM, even with all what I said, that the company will take time to adapt to it. I think this is kind of a good way to enter sometimes, because that's where the hype is. Where knowing also is dangerous. Um, what I see a lot is that it's really less the case as before, that everyone could um, become the scientist. They look a lot of for softwares, engineers and everything, software engineer or just engineers, or things like
Mhm.
this. So really have a good software engineers background is really important to start, I will say. I say the prem sometimes data engineer is the more easy way to get jobs, to get money, and to be able to work anywhere. But it's
Mhm.
not the most exciting part of the job, I feel.
Mhm.
And it's a bit dangerous because going back, especially if you're a very good data engineer, then you start to be as a scientist and then you work with very bad data pipeline, then you will end up working on data pipeline just by default because that's what you're good at. And so you will end up becoming data engineers without you wanting to.
Mhm.
So it's really I have the feeling that if you want to work in data scientist, often just being working in research and then move from research to company is kind of the best way to be a real data scientist. Even
Mhm.
though I feel that the scientists should be a really good software engineers, but
Mhm.
most of the time, if you're a very good software engineer, you end up in that are doing more infrastructure side of it.
Mhm.
Um, yeah, I think that I am for one thing I say often is for people that want to be very technical persons,
Mhm.
take care of become data analyst because you often they also look down as non-technical persons
Mhm.
which can be the matters in the job. They well paid, they got good money, and they work with business, have a lot of impact. But
Mhm.
this make it harder to move to other field,
Yeah.
I would say. And yeah, like I say, also sometimes company analysis can mean very different things. It can mean also data engineering. It can mean also that the data scientist. So you need to take care of it. It will really depends what that means. But but if, for instance, what you like is really the business aspect of it, then it's very good to that analyst is kind of um, where if you yourself less technical yourself and you less confidence in your technical ability, but you really interested in all those things, that analyst could be really good things. Um, and you will have impact. It's really more easy also to, I think in the data words,
Mhm.
based on what I was going to say, it's sometimes very hard to see the value added. So
Mhm.
people put a ton of money on it. It has a
Mhm.
lot of impacts. People that are really good data intelligence win and people lose. So it has impact. People
Mhm.
can pay ton of money to have access to certain data. So I'm not saying it doesn't have impact, but if you are selling socks and you're doing your socks and you're part of building the socks, you know that
Mhm.
your goal is to sell the socks in the end.
Mhm.
Sometimes very hard when you work in data to really understand what you're doing and why you're doing it. And what I like about the business analyst part is that it's more with the business. So it's more the impact you understand. What you are doing for the business, you understand, I would say. Um, so auto enters, I will say find a job for data engineering,
Mhm.
or do research and then switch from there to data scientist.
Mhm.
I start as researchers and then move as data scientists, I will say. I see more and more, like I think I told you that before, is that a lot before everyone could be a scientist. Nowadays, if you want to do real data science,
Mhm.
like real stuff, not just more data analyst jobs or more, it depends what you mean, but you often need a PhD nowadays.
Mhm.
Um, yeah, while data engineering, the PhD is a bit useless. Clearly
Mhm.
useless because there's no research aspect of it.
Mhm.
And usually people that go out of university, they have no understanding of proper software engineering. So
Mhm.
actually often it will be looked down more than it will be helpful, while in that sense will be very useful because you
Mhm.
need to read a lot of about those new models being used.
Mhm.
So there's different way to enters. Me, I started as data scientist and I moved to data engineering and sometimes I regret it.
Mhm.
There's aspect I don't regret it is that I like to work abroad and there's way more demands for data engineers. So working abroad in English is way more easy for me as a data engineers. But sometimes, like I told you, I find it was not like this at the beginning, but I start to find it boring.
Mhm.
Mm, if you want to be data engineers, have big focus on cloud is important right now. There's a lot of certification for cloud, like
Mm-hmm.
the one from Amazon, the one from Microsoft, the one from Google. Do one of them would
Mm-hmm.
be kind of a good things I will say about it. There's some yeah, Pythons is the base for, of course,
Mm-hmm.
everything is done in Pythons. There's still some Java for some pipeline. There's still some um, new other languages used. I know they do some stuff with Rust and everything nowadays, but most of the pipeline you will ever have will be in Pythons.
Mm-hmm.
SQL is just I mean, when you work in data, you need SQL, whatever you do. SQL is the querying the language. And yeah. So I think that will be it, I will say, for now.
Okay.
I mean, for the question you ask. I don't see anything. I can answer the question, don't worry. That's not the
SQL, Python, and
and clouds.
cloud, like the
Yeah.
certificate. Oh.
Mm, yeah. So what I've seen in the field is, especially in data engineering,
Mm-hmm.
is actually things go in the simplification path right now.
Mm-hmm.
Lot of things, like I told you, things need to be easy to be replaced. Uh,
Mm-hmm.
easy to be taken over by other people. Uh,
Mm-hmm.
you need something that is manageable, replaceable, that you could be running the same thing in different fields, in different services, because there's always new fancy stuff happening, things that are cheaper, things that get better, things that can do more AI, things that can do more tracking or things like this. So I know before, when it was a lot of pandas when I started as a data scientist. Then
Mm-hmm.
it moved to Spark when you start to be data engineers, because you need Spark is kind of a little bit like pandas in terms of you need it's an interface to take what you do, what the data need to do. But
Mm-hmm.
Spark is about distributing. So you
Mm-hmm.
have not one computer that run the things, but you have 10 different computers that run the things. So that was kind of the main things I was working on was I was data engineering was all about Spark. And
Mm-hmm.
now what I see is that it starts before all those things were SQL actually. So it started with SQL, then he moved to a bit of pandas, then he moved to Spark. SQL was still there in the meantime, never disappear. It's always there. And then from Spark now is moving back to distributed database. Sorry to be, but more way to store the data with different odd computers working in parallel. So it start to be more and more SQL actually nowadays.
Mm-hmm.
Um, and yeah, I will. Yeah,
Okay. 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 Well, I think that answers most of the question, and
yeah.
that was very interesting. And yeah, I think you want I think you're ready to go. So.
No, 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 no. I can say a bit more. Also, if you want to be data scientist, um, you have your own API as well. Yeah, for the LLMs, it's changing a bit nowadays.
Mm-hmm.
Um, but yeah, sorry, so bad with names. Um, yeah, give me a second. Yeah, so you also can find transformers and everything's libraries that is commonly used. There is the one on Facebook that is the most used by
Mm-hmm.
the companies. It's good to have good knowledge of it if you want to be a data scientist, because it's always the risk as a data scientist is that you're not doing data science when you are recruit for it.
Mm-hmm.
I will say that yeah, the main risk is they recruit data scientists because it's easy to find people, and then you do another data analyst, either you end up being data engineers yourself. Uh,
Mm-hmm.
so being very good at your field, and also when you start, you really need to show that you're really good, because they will be quick to switch you to things that they know will bring value and not
Mm-hmm.
play around, basically.
Mm-hmm.
If they don't believe that you play around will bring something.
Mm-hmm.
So this is how I see it now.
Mm-hmm.
Uh, yeah, I think I talk a lot of the technical aspect, but there's a lot of talking with people that is important.
Mm-hmm.
Especially here, I see the very large IT company I'm working. A
Mm-hmm.
lot of work is it's very complicated to make hundreds of engineer work together.
Mm-hmm.
Uh, it's very different if you're one person doing everything or 2,000 people. So you need to be able to explain your vision to people. You need to be really thorough. Okay, we need to do that. I need to plan. I need to do that. These things. Asking that to this person, making sure I can access these things, making
Mm-hmm.
sure that this person is aware that this is gonna happen this day, and you need to ask this thing at this person's. So there's actually a very business side of it, like more interacting management side of it.
Mm-hmm.
That I've seen some people can become very good technically and then go to the company words. And even though they were the first in the class,
Mm-hmm.
they will kind of stagnate. They will get maybe the first two step very well because they're good and people will see that you ask them to do something, they do it. But then they will be stuck there forever because the job is more about making different people move together. And
Mm-hmm.
so you need really good understanding and a lot of trust on yourself. So people need to trust you. So then you need to be good technically, but you need also to have this human aspect of it.
Mm-hmm. Mm-hmm.
That is actually extremely important. I will say that's true for every software engineering. I
Yeah.
would say more for data
Mm-hmm.
because yeah, there's a lot of rules around data, a lot of who can access, cannot access uh,
Mm-hmm.
and different. You don't have really a lot of full stacks. Full stacks in application can do everything. It's like
Mm-hmm.
different type of very distinct jobs. So yeah.
Mm-hmm. And so like in the because you've worked in like well two very different countries, right? Like China and Japan.
Also Amsterdam and Belgium. But yeah. Well,
Those are yeah, very different countries. Like how has that like kind of impacted your work or
so it's difficult for me to say because when I was working in China, I was working for a Dutch company that had a really not traditional
mm-hmm.
way to work in China. What I
Mm-hmm.
can say is that China is more in advance than Japan for sure.
Mm-hmm.
And what I've seen is that in Japan, they lack talents.
Mm-hmm.
Not that they are bad, it's just they don't have enough young people. And also, young people are not really interested in the data world, I feel, in the software engineering in general.
Mm-hmm.
Um, they tend to go for big companies in cars and things like this. They're not really in the upfront of new technology. Um, while in China, it's kind of an Eldorado. Everyone want to work for Alipay, for Tencent, and that's like the way to success. So even more in India, but it's already there also in China. Um, and you have very, very strong
Mm-hmm.
companies in China.
Mm-hmm.
Yeah, but they have full access to the things, but they are really at the forefront and everything. So, like in China, it was more a field that was really for Chinese, and so as a foreigners, you needed to be Chinese in a way.
Mm-hmm.
And my Chinese is very broken, even though I can speak a bit, but it's very bad. So I could see that there was not really a lot of features as a developers there for me.
Mm-hmm.
While in Japan, like I told you, it's and I work for one of the biggest company in Japan for the tech industry. Um, and it's not the biggest. The 95% of my colleagues are foreigners.
Mm-hmm.
The only Japanese are like the big boss.
Mm-hmm. Okay, okay.
And some interns and new joiners this year were Japanese. So maybe it might change in departments, but in the data fields, I think in the application fields, so creating the application, there is more Japanese. But in the pure data, really, there it's really easy to find a jobs, I will say. So that's
Oh.
kind of the good things to say. I mean, you always like this, so maybe actually in 2 years there's going to be difference. But and you
Mm-hmm.
see they need engineers. You see that the state wants you theirs.
Mm-hmm.
Um, And in the way, often they just let you do foreigner stuff, working in foreigners' way, and then they do the Japanese way.
Mm-hmm.
And it's kind of two different worlds. It's still a Japanese company, but I don't have a lot of interactions with the Japanese words.
Mm-hmm.
Well, in the Chinese words, you need more to fit in, I
Mm-hmm.
would say. These things are general, it's not linked to the data fields. And it's also very dangerous to compare sometimes, because what is about the country, what is about the
Context.
company cultures, and yeah, so it's very, very, very dangerous often to make a full big talk about different country because of that. Yeah, I can talk more about difference between startups and very large company.
Mm-hmm.
I will say in startups more than China and Japan. I would say more startup, big company. I will say startups are, they sometimes need to less respect the rules
Mm-hmm.
in terms of security, in terms of who can access the data, who have access to data, who can do that. And
Mm-hmm.
so you can just create stuff by yourself. You can have very quick iteration of things. Oh, this could work. Let's try it quickly. Let's do that. And then you do it, you work all together, and then you have something. And
Mm-hmm.
then after that, you figure out, oh, you can create a product after it. Now that it's there. So, and then you put a little bit stuff together, but and then you make it beautiful, but beautiful, more beautiful afterward. But yeah, so that's kind of the mindset, way more what we say agile, way more, it's more easy to adapt an agile mentality. So be more adaptive to more quicker first prototype, uh,
Mm-hmm.
and then from there build something. While when you have very, very large company, you cannot really build prototype that might not work, because
Mm-hmm.
you need to make so much people move together in one direction. So you need to have a clear plan. So more waterful mindset often work better theirs. They try a lot of sorry, I'm going more in management. They try to be agile, but often they fail at really doing it,
Mm-hmm.
because there's reality that, yeah, you have so much different engineers in different way that work on very specific things.
Mm-hmm.
Often you try to use what's already available in the market,
Mm-hmm.
to only care about what you want to do with your startup. Often the small details that you will not care about will be taken care of in very big companies. So that's a good side of it. But you
Mm-hmm.
need all people to work and move in one direction. So you need to very clear plans in the next 6 months. When is going to happen? What's going to happen? We're going to give you access to those kind of things. The aspect I was taking you before.
Mm-hmm.
Um, that is way harder to set up like new things that doesn't really work, or you're not sure that it will work.
Mm-hmm.
So doing a quick prototype will be complicated, because just having access to one server, so you need to send one ticket waiting for one person, then access for this specific data. You need to have a certain budget that is allocated for that. You need to
Mm-hmm.
make sure that you can reserve one person working on this, and just getting to the point where you're gonna start, it will be in 3 months. So it's totally different type of
Mm-hmm.
work, but in other hands, because every time you have an idea, you can still make it happen because you have enough engineer to do it. While
Mm-hmm.
often when you start up, you can have ideas, but you're just never gonna be able to really set it up, because you just don't have the knowledge, don't have people to ask questions, don't have enough people to work on it, and you're always stressed because you don't have a proper platforms.
Mm-hmm.
Where those big company will shine is to have those really big platforms, because they can have a lot of engineer working on things that could be reused later and everything. So that's the different type of jobs.
Yeah, like if you have like less scale, you have more flexibility but less resources, and
Yeah,
bigger you go, the less flexibility but also the more resources. So
yeah. I heard that in the US they are really good at keeping the flexibility
mm-hmm.
in those very large company in Facebook and Google. They're really good at is actually having the skills, but still being able to do quick prototype in the same times, and uh, and deploy things very quickly. Yeah, and play around, but in a proper way that is easy to do. So that I think that I heard, but I never worked for a US company. So
I heard it's because like they buy a lot of smaller companies and they keep like the functioning of the startup, but they
Mm,
feed them with money and so
yeah, I can pay people, and then it look a bit too beautiful to be true to me, to be fair. But I understand the idea behind, yeah. And also I think uh yeah. Yeah, also if you pay very a lot of money, then people are really ready to work extra hours in a project while still delivering data on the things. While if you pay very little money, people just do the work and then they just want to leave. That's also possible. Yeah, I don't know. Okay, I will have to go sadly. But yeah, I talk a lot, I'm sorry.
no, no, I mean you went on a podcast. That was the whole idea. All right. Well, thank you very much. That was very interesting, and I'm gonna say bye to everyone now and stop recording.